transformations and graphing rational functions. We're going to talk about the reciprocal family in this lesson, and at the end of it you should be able to graph the reciprocal functions using translations, transformations, stretches, compresses, etc. Let's start. For a class party, the hall rental fee will be split amongst the students attending. Food will cost each student an additional $8. The graph to the right here shows the cost per student based on the number of students attending. Food is not yet included. Now, what is the product of the x and y coordinates? Well, up here we have 40 times 6, 240. 60 times 4, 240. 80 times 3, 240. 100 times 2.4, 240, and so on. Now, what's the practical meaning? Well, here it says that if 40 students attend, we have each one pays $6. If 60 students attend, they only pay $4. If 80 students will attend, then they only have to pay $3. And if you get 100 students, then they'll only have to pay $2.40. So it's number of students. If the given number of students attend, each pays Y dollars for rental. Now, what effect does the food cost have on the graph? Well, if there's 40 students coming and they have to pay $6 to attend and then another $8, that would move this up 8. Likewise, if it was $4, they would then have to pay 12. So the effect of the food cost, it raises or moves graph up 8. It's a vertical translation, 8 units up. Oops, there we go. Now, general form of the reciprocal family. Here is the general form. Y equals A divided by x minus h plus k, where x does not equal h, otherwise you'd have 0 in the denominator, and that would be problematic. Notice the curve gets closer and closer to the x and the y-axis, but they do not touch or cross them. That's because the x-axis is a horizontal asymptote and the y-axis is a vertical asymptote. New word, asymptote. What is an asymptote? And before I answer that question, I want you to notice that this is the parent function. A is 1, h is 0, k is 0. So that's the parent function. Notice when x equals 1, y equals 1. When x equals 2, y equals a half. When x equals a half, y equals 2. And you can draw the curve. Likewise over here, when x is negative 1, y is negative 1. When x is negative 2, y is negative a half. When x is negative a half, y is negative 2, and I can draw. Notice I can't become 0, but the closer I get to 0, the bigger y becomes. The bigger x becomes, the smaller y becomes. Think about that. Now, an asymptote. An asymptote is a line that a curve approaches as it heads toward infinity. As it heads towards infinity. Now, there are several kinds of asymptotes, and we need to know about them all. There are vertical, horizontal, and slant or oblique asymptotes. Slant asymptotes are sometimes referred to as oblique. Horizontal and vertical asymptotes will appear, or may appear, on the SOL. Slant asymptotes Pre-AP Algebra 2 is expected to know about slant asymptotes. Regular Algebra 2 does not have to cover them. Here's an example of a horizontal asymptote, a vertical asymptote, and a slant asymptote. Notice that the curve is approaching. I've got my asymptote, the curve is approaching it. And actually the y-axis here acts as an asymptote, and the curve is approaching it. Asymptotes, unless it is the x or the y-axis, are typically drawn as dashed lines. Now, an important note regarding asymptotes. The curve can approach from any side, such as from above or below for a horizontal asymptote, and may actually cross over, possibly many times, even move away and back again. The important point is the distance between the curve and the asymptote tends to 0 as they head to infinity. So here you've got this horizontal asymptote. It's going back and forth, and it keeps crossing over it. But every time it crosses over, it just keeps getting closer and closer and closer. It's getting down to the point where it is approaching the asymptote. Now, slant and horizontal asymptotes may be crossed. A vertical asymptote may never be crossed. So you'll never touch or cross a vertical asymptote. Here are the three types of asymptotes. Horizontal. A horizontal asymptote occurs as x goes to infinity or negative infinity, and the curve approaches some constant value b. Horizontal asymptotes may be crossed. The equation for a horizontal asymptote is simply y equals b, where b is a constant. There can never be more than one horizontal asymptote. Never be more than one horizontal asymptote. Vertical asymptotes. A vertical asymptote occurs as x approaches some constant value c from the left or from the right, and the curve goes toward infinity or negative infinity. Now, there can be more than one vertical asymptote. The thing about a vertical asymptote is it's never crossed. So I can cross a horizontal, but I'll only have one. I can't cross a vertical, but I can have more than one. Got to remember the difference between the two. Finally, we have our oblique asymptotes. An oblique or slant asymptote occurs when x goes to infinity or negative infinity, and the curve approaches a line defined by y equals mx plus b, where m is not 0. There can only be an oblique asymptote if there is not a horizontal asymptote. An oblique asymptote, like the horizontal asymptote, can be crossed. But notice, if I have a horizontal, I won't have an oblique. If I have an oblique, I won't have a horizontal. Just like the horizontal, oblique asymptotes can be crossed. Why can't m be 0? Because if m were 0, it would be horizontal. Graphing and inverse variation. To graph y equals 8 over x, for the reciprocal function, we only look at the vertical and horizontal asymptotes. A reciprocal function will not have an oblique asymptote. The vertical asymptote occurs anywhere the function would be undefined. What are the restricted values of x, if any? Well, x can't be 0, so x equals 0 is the vertical asymptote. We use a dashed line. A horizontal asymptote is a little trickier to identify. If the degree of the numerator is less than the degree of the denominator, which it is in this case, the horizontal asymptote is 0. This can be vertically translated by k. We will see that in just a little bit. So here, y equals 0 is the horizontal asymptote, and we use a dashed line. Okay, for this, the degree of the numerator is 0, and the degree of the denominator is 1. If the degree of the denominator is more than the degree of the numerator, then y equals 0 plus k is your horizontal. Here we've got it. My dashed line, my dashed line. I can then make a table of values and plot the points. Some very critical points. When -8, it's -1. When it's -4, it's -2. -2 gives me -4, -1 gives me -8. I can draw the curve. Same thing applies on the right-hand side. Now, from when we did this just a little bit ago, you should recognize the general shape. I've got it in the first quadrant and the third quadrant. The domain are all real numbers except x equals 0. The range, all real numbers except y equals 0. Some reciprocal transformations. Pause the video for a moment and study these. Notice the effect of A on the graph. Okay, so did you notice that when A is negative, it's reflected over the x-axis instead of being in the first and the third quadrants? It's now in the second and the fourth quadrants. See? When it's negative, second and fourth quadrants. Positive, first and third. Notice too that the smaller A is, the tighter the curve gets. It's compressed into the asymptotes. The larger A is, the absolute value of A, the more it pulls away from the asymptotes at that center. Okay, so it's stretched vertically and horizontally, or vertically, sorry. Right? Now, the parent function. Y equals 1 over x, x does not equal 0. Remember, those restrictions are important. The absolute value of A greater than 1 is a stretch. The absolute value of A less than 1 is a compress. It presses it towards the vertical asymptotes, vertical and horizontal, or pulls it away. Reflection. If A is less than 0, then it reflects across the x-axis. Y equals A over x, x does not equal 0. Translations. This is when we move it left and right, up and down. Horizontal by h, vertical by k. Vertical asymptote becomes x equals h. Horizontal asymptote becomes y equals k. Very important here. When we combine it all together, here is your standard form. Y equals a divided by the quantity x minus h plus k. X cannot equal h. All right. How do we get that? Well, x minus h cannot equal 0. Add h to both sides. X cannot equal h. That's how we find our restrictions and our vertical asymptotes. Since x cannot equal h, x equals h is a vertical asymptote. And in this case, you always have a constant in the numerator and a degree of 1 in the denominator. So a degree of 0 over a degree of 1, you're always going to have y equals k, or y equals 0 is your asymptote. The plus k simply moves that whole graph up or down. So y equals k is your horizontal asymptote. Now, with that information, pause the video, take some graph paper, and attempt to graph each one of these. Identify the vertical and the horizontal asymptotes, and then sketch a graph. Go ahead and try it. Again, pause the video. Okay. If you're ready to go on, start the video up. Here's the first one. Is it reflected? No. So that means I'm going to find it in quadrants 1 and 3. Is it stretched or compressed? Yes, it's stretched by 3 because A equals 3. Is there a horizontal what is the horizontal asymptote besides x equals, besides y equals 0? Y equals 2. Remember that it's y equals k. Vertical asymptote, x equals 1. Remember that it's x minus h, and h is our vertical asymptote. So you dash in the asymptotes, and then you stretch it. You move over 1. Instead of going right 1, up 1, you go right 1, up 3. Same thing, left 1, down 3. And put a point. And then notice you're pulled out from the asymptote. If I went right 1, up 3, then I can go right 3, up 1. And I put those 2 marks. These are the 2 marks I would expect to have on the graph to show me that, oh, sorry, I've got oops, right 1, down 3, that you've got it going in the right direction, and then it approaches the asymptotes. Next one. Reflected? Yes. Stretched to compressed? No. Horizontal asymptote and vertical asymptotes are H and K. Remember that this is x minus -4. So there's my H value. I draw in the asymptotes, and then my pattern is right 1, up 1. Well, since I can't go right because it's reflected, I go left 1, up 1. Here, right 1, down 1. And then when it's 1, when there's no stretch or compress, that's the corner of the curve. No stretch or compress, that's the corner of the curve. So you can just make it go, if you go over 2, you're at 1/2. If you go over 1/2, you're at 2. And from there, you can just get closer and closer to the horizontal and the vertical lines. Next up, 1/3. Now, yes, this is a fraction and a fraction, but it's to help you understand. You've got to compress times 1/3. You've got your horizontal and your vertical asymptote. Again, x minus -2, and then the -4. So y equals -4, h equals negative, or x equals -2. The 1/3. That means if I go over 1, I'm only going up 1/3. Yeah. If I go over 1/3, I go up 3. In this case, this graph I created using software so that it would look nicer, since my drawing gets a little bit wiggly wobbly. If I were you and I were doing this, I would make a much smaller graph. I would only go out maybe from -5 to +1 or 2, and then from maybe -7 up to +1, something like that, so that I could expand it and make it look bigger. But essentially, when you're graphing it, it just gets close really fast. Does it look like it's touching it? Yes. And that's because when we draw a line, there's actually a thickness to the line. Finally, we have another one that's reflected. So instead of being in the upper right, lower left, we're in the upper left and lower right. We've got a stretch by 2. Y equals 3 is our horizontal. We don't have h is just 0, so we're still on the y-axis. Because it's stretched by 2, I'm going to go left 2, up 1, left 1, up 2. There are my 2 points. Whatever I do to the right, I can do to the left, and I've got my curves. In summary, the parent function, y equals 1 over x, x cannot equal 0. You've got your stretches and your compresses and your reflections, and your translations. Notice that this is for a very specific type of rational function, and that's the reciprocal function, 1 over x, or x to the -1. Here's the parent function. You are responsible now for yet another parent function.